In India, about a millennia or two ago, people wrote fractions as just two numbers, one vertically placed on top of the other. For example, 8/3 was just written as 8/3, like that. No bars, no nothing like this. Grand and good, they had fine time doing mathematics with fraction notation written that way. I believe other countries did the same thing. I think there was also common practice in China, but I could be wrong. Yeah, but historically, fractions were written like this. So around the year 1200, a Persian scholar, Al-Hassar, said, okay, that's a little hard to see. Let's group these together. And he did a little bar. He drew a little bar like that to say, let's make it a little clearer and easier on the eye to see it really is 8 on the top for a numerator, 3 on the bottom for the denominator. They are tied together. Now, he wasn't thinking Vinculum. But when Fibonacci came along and saw this work going on in Morocco, he said, oh, look at this. He said it looks like a little twig, like a little piece of a tree, of a branch. So he used the Latin word for twig and called this a virga. A virga. All right, so the fraction bar is technically called a virga, the Latin word for twig. People weren't thinking vinculum, but here's the thing. It actually behaves like a vinculum. For example, if I were to write 6 plus 2 virga 3, or 8 over 1 plus 2, or combine them, 6 plus 2 virga 1 plus 2. I'm looking at these and saying, you know what? I know it's not a vinculum, but it's behaving just like one. This 6 plus 2 is all it's one group. This should be 8/3. It's this number. Or again, off the bottom, this virga is behaving like a vinculum. Group the 1 and 2. Do that. Get 3. It's really 8/3. Or do them simultaneously. Looks like this virga is actually grouping the 6 and the 2 and the 1 and the 2. Get 8/3. So the virga is behaving like a vinculum. Let's actually think about it like a vinculum, and grand is good. In fact, if you look at some on the internet, you'll see lots of authors do actually call this a vinculum, not a virga. All right, but that's okay. It's a vinculum, fine. It works just like one. Let's do that. So that then helps us with, I need something to erase. Hang on, I'll get a little paper towel. Some common algebraic struggles for students. For example, the one I said last time was a common mistake with 3x plus 5 divided by 3. It seems very tempting. I get the temptation, just cancel out the 3's and get x plus 5. But here's the thing. You need to say, no, there's a vinculum here, vinculum. All this is one group. You can't just divide part of a grouped thing by 3. All of it gets divided by 3, or none of it gets divided by 3. Make up your mind. In which case you say, okay, I must have made a mistake. I can't just cross out the 3's there. It's only dividing part of that group by 3. So how am I going to handle this instead? Now I've got a couple of approaches. One is to actually think, what are fractions? I mean, this is kind of a fraction. It is a fraction, just don't know what the numerator happens to be. It's like 8/3. It really is like 8 copies of a third. So let me just write that out. It's like this many copies of a third. It's really 3x plus 5 copies of a third, and be very clear, put them in parentheses, we'll use a vinculum. So that's what that expression really is. And now I can see what it really is. It's actually multiplication, because actually I don't believe in division. There it is. There's the multiplication. So what is this? What is 3x plus 5 times a third? So I'll do a quick little area model thing for myself. I got 3x inches and 5 inches to be multiplied by 1/3 of an inch. I can now see I'll get one piece that's x inches squared and 5/3 here. This must be x plus 5/3. Great. I see some students that prefer something that looks a little more complicated, but it works for them. If you don't like fractions over 3, people like fractions over 1 instead, because then you don't have to worry about it. They say, okay, I'll just make the denominator 1. How do I do that with fractions? Well, I can multiply the top and bottom by whatever I like, as long as I keep it balanced. I'll multiply the bottom by 1/3 and the top by 1/3. There's an equivalent fraction, right? All that gets multiplied by 1/3. Watch out for that vinculum, that virga. And I say, okay, I can think of this as 3x plus 5 on the top times 1/3 times 1/3 all over 1. Any fraction over 1 is just the top, 3x plus 5 times 1/3. And now I'm back to doing this work, and I'm back over here. Okay, but there it is. My point is, think of the fraction bar as a vinculum. Don't violate the vinculum by only dividing part of a group by 3, multiply everything by 3, or rewrite it as a fraction, or however your mind wants to go. You can actually make sense of this if you see that grouping for reals. All right, so let's do another couple examples. For example, in a pre-calculus class, students are required to simplify rational expressions because they just are. All right, so let's do an example like that. You see what I think of that. All right, clean the board, and by clean I mean inverted commas clean. Let's do this. Example. Please make 1 over x plus 1 over y over 1 over xy look friendlier. Let's try that one. Let's make it look friendlier. I don't like the word simplify. I don't really know what simplify means. It's very subjective, and I don't know what's considered simple. Friendlier feels better. I still don't know what's considered friendly. Maybe that looks friendly to you, in which case, say great. But to most people agree, they don't think this looks friendly. Look, I've got fractions within fractions here. So what could I do to make this look friendlier? Well, I certainly don't like fractions in the denominator, and I certainly don't like fractions in the numerator, but that denominator, I feel like I know what to do. I can use facts about equivalent fractions. I can multiply the denominator by anything I like, and the numerator by the same thing. I'll keep the fraction balanced. And I'm going to choose something that makes this bottom equal to 1. I'm going to multiply by x times y. X times y. What will I get now? Well, on the bottom, I'll get 1 over x plus y times xy. That's just 1 on the bottom. And I'll get xy times 1xy. And 1/y of x times y plus x. I can see this is just x plus y. And I think anyone would agree that actually does look friendlier. I'm going to go with that word then. All right. Thinking about fractions, properties of fractions, and this grouping symbol, life can be so much easier and grand. All right, let's do one more. Let's do one more example. Let's do one with nested vinculums, nested virgues, to be honest. I think I did this example in a previous video. Let's evaluate something that looks nasty. Example. Please evaluate 1 plus 1 over 1 plus 1 over 1 plus 1. All right. So if I'm thinking in terms of my vinculum mindset, I'm seeing vincula within vincula. And my experience with nested vinculi is to do the innermost vinculum first. And the innermost one will be this one. And I see it's got a 1 that's being grouped as 1. And I see a 1 plus 1 that's being grouped together as well by that virga, by that vinculum. So this is actually, here's my answer. 1 plus 1 over 1 plus 1 over 1 plus 1 is really 1 plus 1 over, leave the rest the same, and I'm going to evaluate that one right now, 1 plus a half. All right, what am I going to do now? I got 1 plus, here's my grouping, here's the grouping, focus on this next right now. Okay, numerator's fine, the bottom's got halves in it, I don't like that. I'm personally going to multiply the top by 2 and the bottom by 2. Now I'm going to get, bad bore technique, still the 1 plus 2 on the top, and double 1 and double a half. This is 1 plus 2/3. Okay, now I'm saying it's 3/3 and 2/3. I can see this is actually 5/3. It's 5/3. But my point was with this one, complicated rational expressions with fractions within fractions really say, like vincula, nested vincula, go to the innermost one first and work from there. I've had students, when I gave them this very problem, start trying to work with this one, 1 plus something, and then they got stuck because they didn't know what to do with that oneness. So they attached this 1 over here. I don't, it's very confusing. It's very confusing. Go to the innermost vinculum first and work your way out from that. And that's holding for this fraction notation. All right, so okay, a fraction bar behaves like a vinculum. Let's treat it like a vinculum, and life becomes so much simpler and easier.